Hello students, welcome to Veranda IAS. From the current affair topics of science and technology, in this session, we are going to learn about the China's East. The learning objective of this particular session will be discuss China's experimental advanced superconducting tokamak, okay, which is nothing but in short form we are calling it China's East. So remember again, East means experimental advanced superconducting tokamak, which belongs to China. Further, we will examine the China's East in the news, and then we will explain the working of the East. Further, we will list the records of the East. That is, again repeating the long form of East, experimental advanced superconducting tokamak. Remember that. So let's move ahead by introducing ourselves to the China's East. So the East reactor at the Chinese Academy of Sciences Institute of Plasma Physics in Hefei, China. It's a reactor basically, which is located in one of the Chinese Academy of Sciences, with the location is specifically the Hefei in China's region. So then the goal of this is basically what, whenever it comes to tokamak and the reactors, this type of reactor, basically it is nothing but an artificial sun. Okay, an artificial sun means what? The replicating the procedures which are there in the suns. And what is the procedure in the sun? It is of nuclear fusion. Okay, so we have studied nuclear fission and fusion in the traditional parts. So here we are focused only on the nuclear fusion. The goal of the artificial sun is to replicate nuclear fusion, the same reaction that drives the sun, and that's why it's also called as an artificial sun. And there is also one significant project globally known as ITER, which is in Europe, where India is contributing, but still this is independently of the China. Now, why it was in news? The HL2M tokamak is the China's largest and most advanced experimental nuclear fusion research device. So it is most advanced Chinese fusion reactor, in simplest terms. Now again, why it is significant? Because see, this is like artificial sun, and the sun provides large amount of energy. So if this is achieved, then large amount of energy will be achieved. So that's why every now and then we are talking about it. So this device was successfully powered for the first time in December 2020, marking a significant milestone in China's nuclear power research capabilities. So that is the advancement which China has achieved, and that was in the news, and because of that only we are learning. From exam point of view, now they can ask you a question like this tokamak, to which country it belongs, so obviously the China. So that kind of question, match the pairs or the statements on it, can be asked on this in prelims. Now the EAST project is part of the International Thermonuclear Experimental Reactor ITR facility. So that's what I told you, ITR of the Europe, it is the part of that also, which will be world's largest nuclear fusion reactor when it is completed in 2035. So the objective, like there is this complete one session where we have dedicated ourselves to the International Thermonuclear Experimental Reactor. So I am not going in details of this because it has been discussed in this session itself. Moving ahead, now what is the working of EAST? Now see, working of EAST is based on fusion. Okay, and fusion is what? When two lighter nuclei traveling at very high velocities, generally the velocity is equivalent to the speed of light, they collide with each other, and when they collide with each other they produce a large amount of energy, and these nuclei they combine together and they form a stable element. Okay, for example, or mostly this is only the case, and the sun also operates in this way. The nuclei of deuterium and tritium, they are both isotopes of hydrogen. What type of isotopes they are? So deuterium is having, obviously as they are isotopes of hydrogen, they will be having one proton, that is the atomic number will be 1, but it has one proton plus one neutron, so the atomic mass will be 2. Then tritium is again another isotope of hydrogen, which will have one proton as it is isotope, but it will have two neutrons. So the atomic number will be 3, or atomic mass will be 3. Okay, again I will explain. The nuclei of deuterium will have one proton and neutron, that makes atomic mass to be 2. Then in tritium it will have one proton, that makes its atomic number 1, but whereas the atomic mass will be 3 because it will have one proton plus 2 neutrons. Okay, so tritium is again, it is a radioactive active isotope of an hydrogen. So these again, it can be detected, generally it is symbolized as D, and this is normally the symbolization of tritium. Now one more thing, we also have the normal isotope of hydrogen, which is called as a protium, and this protium, whichever we, this H2O, whichever we have this H, it is the normal isotope of hydrogen. What it has one proton and 0 neutrons. So their atomic number will also be 1 and atomic mass will also be 1. So these are the 3 isotopes of hydrogen. Now what happens if these two, deuterium and the tritium, they collide with each other at very high velocities, and once they are colliding with each other, what they will be producing is they will be producing the helium element 4He2. Okay, helium, which is an stable inert gas, or what you can say stable element, because its orbits are fulfilled, so it will not react with anyone. This is what actually happens in the sun also. In sun, these two isotopes of hydrogen, they collide, they produce the 4He2, and then again by the calculations and all those things, one neutron is released in this process. But then we don't need to get into technicals and details and all those things. But this is the way. When the sun will die, sun will be a completely, it will have only the helium. So helium, the process gets converted into the helium. So further, both of which are found in hydrogen are fused together to produce a helium nucleus. That is what I explained you. A neutron and a lot of energy. So see, it's like when two speeding vehicles collide with each other, what happens? The damages happen, like there may be large amount of noise that is created. Now why it is created? Because the energy that the cars have got because of the velocity is released when they are hitting each other, and that release of energy will be the deformity of the cars, the noise that is it is creating, and all those things. So same things are happening over here also, right? So the fuel is, now in this thing, fuel is heated to around 150 million degrees Celsius, causing a hot plasma soup of subatomic particles. So basically this happens now, heatings and all those things to get that energy. We know sun is itself a plasma, so plasma will be created. So this is the simple working, just simply deuterium, tritium colliding with each other and releasing large amount of energy with a helium and a neutron. Fine. So this is the simple working of the yeast. Now what are the records of yeast? Because of certain records that it made, we are studying that. And what are the record? A new record by reaching a plasma temperature of 216 million degrees Fahrenheit and running for 20 seconds at a temperature of 288 million degree Fahrenheit. This is very, very, very high temperature. Okay, this is a temperature almost equivalent to the temperature of sun. Now, if you are able to create the temperature of the sun on our planet, that's why this project is significant, because the amount of energy that it will be generating will be significant, or will be sufficient enough even to satisfy the needs of the energy needs of the world. So that is the record. This project is positive development for China's green energy growth. Why? Because this form of energy is clean source of energy, because it does not consider, it is not the energy that is produced by burning fossil fuels or using the hydrocarbons. Whenever we are using the fossil fuels and the hydrocarbons, what is the case? The energy generated will not be clean, but this source of energy is clean. So when China is speaking about the green growth, this project will play a significant role. In 2020, the Korea Superconducting Tokamak Advanced Research Reactor in South Korea broke a new record by holding a plasma temperature of more than 100 million degrees for 20 seconds. See now, these are 20 seconds. You may say it is for a very small period of time. But yes, it is in the initial stages. For 20 seconds, even if you are able to reach that, that is significant. In the times to come, it will change, and it will be creating new records, and we will be able to sustain this kind of energy. And once it is created, that means like it is like sun. It is the sun only. Whenever the sun dies, sun will die after billions and billions of years. But that period, it will be providing a non-stop source of, it will be non-stop source of energy. So we are creating an artificial sun. This has been created by China, so that's why we are studying this. Now to summarize what we have learned, so it was a very simple and very straightforward topic. We have studied the China's experimental advanced superconducting tokamak. Further, we studied China's yeast in the news, whatever the news that appeared. And further, we studied the working of yeast, which is based on nuclear fusion. Remember that. And further, we studied the records of the east that they made for the 20 seconds. The amount or the temperature at which they reached is very, very significant. With that, I hope you have understood the very simple topic of China's east, that is the artificial sun. That's it for this session. See you in another one. Thank you.